My name is not really Luke. I just play that on weekends. My name is really Kenneth Lynn. I'm a senior director at WSP, head up facilities planning. So if you ever need a metro system, a commuter rail, a bus transfer center, or an airport remake, come on over. We've got a chat. And then Russell here's one of our senior transportation planners who does the actual nuts and bolts of the modeling. So before we start, we'd like to do a little audience participation here. It's a multiple choice question. There's going to be about 3 or 4 choices. I'd like to see a show of hands. And the question is this: which mode in the United States, public transit mode in the United States, carries the most passengers nationally? So your choices are going to be commuter rail, subway, light rail, or bus. So let's do a show of hands for commuter rail. Who believes that that's the one that carries it the most? Okay, not a single vote for commuter rail. How about subway? Okay, there's a few here. Light rail, like the ones we see running outside here. Nope. Okay, so you guys must be all holding your fire for the last choice, which is bus. Okay, great. Well, you know, the buses use city streets, and one of the things that we find particularly helpful when we're planning improvements in transit services is, of course, PTV software, which helps us out in a lot of that simulation. One other question I'd just like to ask the audience here: who amongst you guys are a regular bus user? Now it's, oh, well, this is great. So sometimes I've had people say, well, you know, I'd like to admit it, but I really can't. You know, it's seen as somewhat, you know, you don't talk about it in polite company, but this is great to see that there's so many people who actually use the bus. So for those who use the bus, this presentation is directed at you. For those who haven't converted to the bus, this is also directed at you. So either way, heads you win, tails you. Okay. So when we came up with this simulation, we use it for major projects. Imagine you're building a bus terminal, could have 2 floors, 3 floors, maybe 5 or 6 floors, maybe a couple hundred gates. Now, when you're running a facility that size, or it could be at an airport, there are certain protocols because you have a lot of buses coming in and out. To avoid conflicts, to avoid traffic jams, accidents, terrible things that could delay folks and just ruin people's days, we have to put in place, just like the railroads have. The railroads have a strict book of rules, a very strict operating procedure, same thing that we've done for the buses. So when we come up with a simulation, first thing we have to do is we have to come up with the rules of the road, and there's certain ones that we use to avoid conflicts. Russell will talk a little bit more about that in a moment. And then what we do is we code that in. So the transit facilities could be, here are some of the characteristics. It can have also a special bus only on ramps and off ramps. The one in Denver here, for instance, has a special bus only ramp that allows you the buses to avoid city streets and traffic. Very handy feature. And then, of course, we also are very concerned about the geometry of how the buses actually berth at the gate. There's 2 common methods. One is a deep sawtooth. That's the one where a bus comes in and it has to back out. Has some advantages. It saves a lot of space, but the problem is when it backs out, it can be a hindrance to traffic. On the other hand, the shallow sawtooth, those are very nice because the bus enters the bus bay and leaves in the same direction. Now, you're probably anxious to see what both of them look like. We've got some animations on that coming up. And when we're working on large bus facilities, not the ones that have just say 10 or 12 bays, but you know, maybe hundreds of bays. Here are some of the flowcharts that the whole ecosystem here is sort of documented of these are the various things that could happen with a bus. And during the AM, if it's going into a bus terminal, it's easier. All we have to do is bring buses into the facility, and then where people get dropped off, they're not too terribly concerned as long as it's not too far of a walk. The main thing is they just want to get off the bus and on their way. On the other hand, in the afternoon, things are much more complicated because people are funny. When they go home, they want to make sure they're on their specific bus and not just choose any random bus. So we have to make sure that the buses actually arrive at the same gate. And then if you throw in urban traffic, which is sometimes known to happen, that can delay things. And then if the bus is late, that's detrimental. because now the crowd is really gathering. It's usually an impatient crowd. And so the cascading delays start to take effect. And if we're not careful, they can snowball. So we try to engineer out, plan out these methods of preventing these things from happening. But sometimes life happens, delays happen, and so we also come up with recovery plans. And one of the ways that we can help with this is, for instance, if you are lucky enough, you can have a staging or storage facility. I consider this to be like a feed bag that takes buses in the middle of the day, and then in the afternoon it kind of expels them out for just-in-time arrival. If you can do that, that really helps out. You don't have to do it for all the buses. You just have to do it for enough of a percentage of your bus traffic to make a meaningful contribution.
Right. Thanks, Ken. So we went ahead to, we struck out to develop a VISM model of this intercity bus terminal. And we wanted to make sure that this bus terminal had all of these unique operational rules that you see on the screen right here. One thing I want to point out in particular, the bus-only ramp system that you see mentioned at the bottom, we really want to make sure that that the queues for the bus ramps don't back up onto the different floors, so that the activities that are occurring on each floor plate can go unimpeded by backup queues. So we modeled an alternate feed merge on these ramps in order to minimize the queue lengths. And as Ken mentioned, we have the different operations between drop-off buses and pickup buses, and then also the routing between the gates, staging and storage, and then the recirculation. So we developed, we call it an agent-based simulation program, which basically means we added a bunch of scripts to the VISM model so that it can get the buses to operate the way that we want them to. So this simulation program will guide buses to any open arrivals gate, and then subsequently either send that bus to a designated gate or to a staging and storage area. It can handle early or late arriving buses, and it can also it also has the bus recirculation rules built into the simulation. The agent-based simulation will also handle the dispatch from the staging area. We analyze a bunch of different staging concepts. The terminal model also had different sizes for bus gates. So your standard buses, your articulated, double-deckers, vans, and etc. We also analyzed a bunch of different incident scenarios, such as lane blockages, gate blockages, ramp blockages, and for the script we use Visual Basic. In terms of sort of the more VISM-specific coding, we use the public transport lines, and then we coded in the departure schedules into the PT lines. We used, as Ken mentioned, we used deep sawtooth gates along with the shallow sawtooth, and we used the parking spaces for the deep sawtooth instead of the public PT stops. Partial PT routing decisions, that's for your the recirculation for the public transit lines. And as I mentioned, the parking lots for the bus loading and unloading, and then the reverse backing out, we coded that in for the deep sawtooth. And then so for the deep sawtooth, we actually coded in signal bars so that, and then with the script, this would cause buses that are in the outside lane to pause and let the bus complete backing out before being allowed to move forward. So since picture's worth 1,000 words, we do have a few animations of these different concepts that we analyze. So this is the deep sawtooth, as you can see. So you can see the different buses and vans moving out, and then you can see how the other buses are waiting for them to pull out before moving forward. So I think this one right here, you can see he pulls out, and these guys, they don't move forward until he's completely backed out. So that was one of the things that we coded with the event-based script. And then this right here is the shallow sawtooth configuration. A little bit more standard with the pull forward and pull in, pull out. As you can see on the left side here, this is the exiting ramp right here in blue, and then this yellow is the entrance ramp. And then you see this section here is for the recirculation. So as I mentioned before, we really, if we have queues for the buses exiting, we really want to make sure that they don't back out onto this floor plate because that would impede the recirculation. And then lastly, we have here the bus staging level. We call this the racetrack concept. One of the things you'll see on this entering ramp over here, the buses were changing color. And that is because we had the buses, when they cross this certain point, they actually change vehicle type. And so that impacts what kind of routing, PT routing decision that they'll follow once they get to a certain area. And then each row represents a different bus level within the facility for the different buses.
Yeah, on the racetracks, one of the things that we have to do on the simulation is we have to come up with sort of the real world operating procedures, and that has to oftentimes be vetted with the client and accepted by the client. Then we simulate it to make sure it actually works. So in the case of the racetrack scheme, we were trying to resolve a very interesting problem. Buses arrive at your facility at random times. Sometimes they arrive just in time. That's perfect. And sometimes they arrive hours early. And so what do we do with these buses that arrive in these broad ranges of time? And then how do we sequence them so that they flow out and pull out to their gates exactly at the same time that they need to be? So the idea of the racetrack scheme is that if you have, say, one of the, let's go back to that graphic for a second. If you can designate different lanes to correspond with different time windows for their departures. In an example, let's say that these are buses that need to go to the gates between, say, 5 o'clock and 5:09 p.m. So buses can arrive randomly, and then, but this would be for buses going from 5 o'clock to 5:09. This could be from 5:10 to 5:19. This could be from 5:20 to 5:29, and so on and so forth. Or if you have a lot of buses, you can increase the granularity. You know, instead of 10-minute windows, it could be 6-minute windows. It's whatever we need it to be. And the idea is that this way buses would be notified when they arrive which lane that they should go into. And then when they go out, they come out as a platoon in mass. And then that lane then becomes available for another time period in the future. And this way we constantly keep the buses sorted in the sequence that they need to be.
So for the modeling process, we put in a number of different inputs as well once we had fully developed the model, and we were able to do a bunch of different things like sensitivity analysis for like different volume inputs, number of buses, headway adjustment, and as well as dwell time variation. So how long can buses be stopped to pick up or drop off passengers? And then for the MOEs, for the outputs, pretty much the traditional ones, the vehicle processing, queue lengths, and then delay and travel time.
So at this point, you might think, well, you know, I don't really have a need for a 5-story or 4-story bus facility. You know, what's in it for me? Well, perhaps your city or local area is sponsoring a major event. Olympics, maybe a Super Bowl or something like that. Anything that requires a surge crowd processing, or maybe you're trying to attract cruise ships with surge capacity, or you're trying to plan emergency evacuations. Now, the idea is we're going to do emergency evacuations. Obviously, you want to do this in advance and not do it on the day of the emergency. But the idea is that, or you're an airport operator, and you're planning an expansion of your ground transportation facility, whether it's public transit buses or for hire vehicles such as Uber and Lyft. These are some of the ways that this could be repurposed and re-envisioned. So last night I missed out on the reception. And the reason why I missed out on the reception is I was checking out the bus terminal and checking out the light rail. This is sort of what I like to do in my spare time. You know, we would love to chat about this. Here's our contact information. We're not trying to sell you anything. We always enjoy chatting about this. And so give us a call or send us an email, actually.